Hello everyone, my name is Angus Krishnamurthy and my topic is about predicting trends of COVID-19 through a multi-layer perceptron neural network. So to give you a bit of background information about this topic, COVID-19 is basically a virus that's obviously been impacting us as a society, and genetic lineages of it have been circulating around the world ever since the start of the entire pandemic. And COVID-19 has developed many variants where there are still no vaccine for it, including the Delta and Delta Plus variant, which is still affecting us today. And the structural integrity of the original COVID-19 virus would still have been intact, but these mutations are much more harmful than the original COVID-19 virus. And now another specific type of variant that has been shown is the Mu variant, which was first seen in Colombia on January 11, 2021. And the Mu variant is highly resistant to sera from COVID-19 and all the vaccinated individuals, which shows that there really is no cure for the specific variant right now. And from previous studies, combined multi-layer perceptron neural network and a Markov chain model, which is basically a statistical analysis test, was used as a prevalent strategy to analyze COVID-19. And the main goal of this previous literature was to predict the number of future patients and deaths from COVID-19 in general. So basically future death cases and future discharge cases. Now, the overall project goal of my study is to develop an algorithm that can predict future trends of death cases due to COVID-19 per day in each county of the state of New Jersey, hospitalizations due to COVID-19 per day in each county of the state of New Jersey, and the COVID-19 infection rate of each county in the state of New Jersey. And I'll explain more about the infection rate later in the presentation. So how I set this experiment up is I use a multi-layer perceptron neural network, which was used to predict trends of COVID-19 based on numerous factors. And the MLP model was really coded through Python using the NumPy library and the Pandas library, which was used to really import training data. And basically on these graphs, the predicted data is shown from the multi-layer perceptron neural network and is compared to the actual data, which was garnered from a website. So in the results section, the first result shows that the multi-layer perceptron neural network model's predictive average COVID-19 hospitalizations per 100,000 people were not really that similar compared to the actual average of COVID-19 hospitalizations per 100,000 people, as there is really a low R value. So in this case, the R squared value is 0.1921, and the R squared value really measures the goodness of fit. And since the R squared value is relatively small, this means that the goodness of fit of this model is not really that high. So the MLP model's predicted values was not really that good compared to the actual average COVID-19 hospitalizations per 100,000 people. But in the next one, the MLP's model's predictive average COVID-19 death cases per day was pretty similar compared to the actual average COVID-19 death cases per day, as there's a relatively moderately high R value. And in this case, R squared again measures the goodness of the fit. And in this case, the goodness of the R squared value is 0.3846, and this makes the goodness moderately high. So this is obviously much better than before, where the predictive average COVID-19 death cases per day is pretty similar to the actual average COVID-19 death cases per day. And then finally, the predictive infectious rate of COVID-19 is extremely similar compared to the actual infectious rate of COVID-19, as there is an extremely high R value. And as said before, again, the R squared value measures the goodness of fit. And in this case, the R squared value is 0.9944, which makes the goodness very high. Now, to calculate the infectious rate, you basically just divide the number of hospitalizations per 100,000 people by the number of average death cases per day, and then you just get the infectious rate, and you do it for both the predictive side of it and the actual side of it. And then finally, overall, it was shown that all three correlations were statistically significant with one another, and it can be assumed that the actual data has been collected can be used to predict more data in the future for a 14-day cycle. But however, there have been some limitations in this study. For example, it was hard to find like mu variant data in the state of New Jersey. So going forward, more data should be collected and analyzed. And then the main limitation in this study is specific parts of the multi-layer perceptron neural network, which should probably be trained more in order to understand it better. So future implications can look into more about the MLP model and how I can train it through COVID-19 data so that it can predict mu variant data with more accuracy. And here's my works cited. Thank you.